Today's topic is LPP, that is linear programming problems. And we're going to learn how to frame these linear programming problems. See, the question given is a manufacturer produces two types of models, and the models are M1 and M2. Each model of type M1 requires 4 hours of grinding and 2 hours of polishing, whereas model M2 requires 2 hours of grinding and 5 hours of polishing. First, we have to make the decision. The first step is the decision variable. So, this is how we are going to solve it. So, the solution is this forms a part of the solution. Now, first is the decision variable. We will take model M1 as x1. So, x1 variable is used for model M1 and x2 variable is used for model M2 respectively. So, x1, any decision making regarding M1, that is model 1 M1, will be stated as x1, and for model 2 it will be stated as x2. So, this becomes our decision variable. Now, what is our objective function? Next step is objective function. What is objective function? The purpose for which we are forming this LPP, that is linear programming problem. Over here, see, it's said that the manufacturer has two grinders. So we have to find out that the manufacturer has two grinders and three polishers. And each of the grinders are used for 60 hours a week, and each polisher works for 50 hours a week. Profit on model M1 is rupees 4 and M2 is rupees 5. Now, how should the manufacturer allocate this production capacity to the two types of models? So, basically, what it means is we have got two kind of models. One is M1 and one is M2. And both of them use a combination of grinding as well as polishing. And the manufacturer has certain numbers of grinders and polishers. So, in what order or how much should the manufacturer use the grinders and the polishers for production of M1 and M2 so that he produces the maximum profit? So, that is why my objective function here, we will take it as the function of Z. Z means what the manufacturer has. So, the manufacturer has 4 and 5, that is 4 rupees profit he will make by production of M1 model. So that's why I've written 4 profit for M1 model, and M1 is stated as X1 because we had already taken X1 as M1 and X2 as M2. And another thing is rupees 5 will be his profit for model M2. So I've written M5 over here, and for M2 it is X2. So this is basically for model 2 and this is for model 1, M1 and M2. So this is his profit. So this is taken as number 1. Next, what are the constraints? Constraints are what are the two factors that we have to keep in mind so that we can maximize our profit. So constraints are, for the first machine, there are two types of machines that the manufacturer has. First is the grinder, and then also he has got polishers. So he has got two grinders and he has got three polishers as well. So that is why I'm going to write over here how many grinders they have. They have got two grinders and each grinder works for 60 hours. So 60 into 2, 120 hours is the total weekly hours the grinder works. And so that is written over here. You can see 60 hours a week and two grinders. Each grinder working 60 hours a week. So this becomes my first constraint. Then what is my second constraint? Second constraint over here is given that he has got three polisher and each polisher works for 50 hours a week. So see, over here it stated that there is 50 hours working, and there are number of polishers are 3, so 15 to 3, 150 hours. That means that total working hours for the grinders are 120 and for the polishers are 150. Over here, now we have to see that grinders and polishers both are used in case of model M1 and M2. Over here, it is stated that for M1, 4 hours of grinding is required. So for M1, we require 4 hours of grinding, and for M2, we require 2 hours of grinding. So 4 hours and here 2 hours. So that is why I am writing over here, because X1 means model 1. So we are writing over here, it requires 4 hours of grinding, and model 2 requires 2 hours of grinding, and total number of hours for which the grinders can be used is less than or equal to 120. That means within 120 hours we have to complete this work. So that is why is less than equal to 120. Next, equation C is formed. Why? Because it's stated over here that the next machine that we are using is the polisher. So you can see that over here it's stated that 5 hours of polishing is required for M2 and 2 hours of polishing for M1. So M1 is stated as X1 and 2 hours of polishing is required. So we are going to write it over here this way. 2 hours of polishing required. X1 is basically the model 1, and for model 2, 5 hours are required. So 5 over here and X2. And total the polisher can be used for 150 hours. It's stated over here because 50 hours it can be used in a week, and 3 polishes you have got. So 15 to 3, 150. So again, this is stated as less than equal to 150. Now, what are the two things that we are using? X1 and X2. These are the two machines on which these two machines are going to work. So non-negative restrictions are X1 and X2. These are the two things in which we are going to use all these machines. So my equation becomes max z. Max z is used for what? Max z is used for our objective function. To state the objective function, we are going to write max z, and we are going to just simply copy the objective function. That is for X1, that is my objective is what? To attain the profit. So 4 rupees profit for by production of machine 1, model 1, and for 5 rupees for machine 2. So that is why this is my max z. My objective is to maximize our profit. That's why max z. And then after that, we have got the constraints, and over here we have got the first constraint, that is this is related to my grinding machine. So 4 hours in model 1, 2 hours in model 2, and total grinding machine can be used for 120 hours. And the second constraint that we have got is 2 hours of polishing machine used for model M1 and 5 hours for model M2, and total working hours is 150 because it's already stated that he has got 3 polishing machine and each works for 50 hours only, and we have got 2 models to work out these things. So this becomes my equations. So these equations are together, all together known as the LPP, and we have got different methods to solve this equation.